Hello, I'm Fabrizio Pastore from University of Milano Bicocca, and I'm going to show you Mesh, a tool that is plugin compositions. This work has been done with Leonardo Mariani. Modern development environments are built upon plugin architectures that allow users to run on the same environment different tools. For example, here we can see in this picture Eclipse with different plugins. We have JUnit that allows the users to execute test cases and show their result. And we have Eclemma that measures test cases coverage and also shows in the Eclipse editor the lines covered during the execution of test cases. Having different tools in the same environment allow smart user to find new solutions just by composing these tools in a new way in order to solve their problems. For example, a user may decide to combine JUnit and Eclemma not to measure code coverage, but to find bugs. For example, a user may run passing test cases with JUnit, measure their coverage with Eclemma, then run failing test cases with JUnit, and then measure the coverage with Eclemma. Then the user can compare the coverage of failing and passing test cases and do this in order to find the bugs, because bugs are probably in the code executed during failing test cases but not in passing ones. And when this new combined solution work, the user wants to automate it in order to apply it on different projects. Unfortunately, automating these manual compositions with current development environment is difficult. A user needs to implement, for example, in Eclipse, you need to implement a new plugin to design this and implement this composition, and then learn the APIs of the plugins that you want to compose, and write a lot of glue code, and finally start a new instance of Eclipse in order to run this composition or debug it. We think that plugin composition should be much more easier, like drawing the workflow on a paper. We introduce the idea of a task-based plugin as a solution. Task-based plugin for us is a plugin that exposes its main functionalities as tasks that can be combined by users in workflows that can be executed automatically. And this task-based plugin can also export workflows in order to allow users to build hierarchies of workflows in order to build complex workflows. We implemented this idea in Mesh, which is an Eclipse plugin that augments Eclipse with the notion of task-based plugins and workflows of this task. Mesh uses JOpera, which is JUnit, which is an Eclipse plugin that provides a workflow engine and a workflow editor. Mesh provides an extension point that allows plugin developers to implement plugin tasks, that is, tasks that provide the functionalities of the plugins. And for each task they define the name and then can define the inputs and outputs. Mesh then allows users to define workflows with multiple instances of the task exposed by the plugins installed on the platform. The user just needs to select the task to instantiate from a list that is automatically populated by Mesh. Then the user can draw the workflow just by connecting input and outputs of those plugins. In this way, users can define workflows of the functionalities exported as tasks. But we know that not all the functionalities could be exported as tasks, because we already have a lot of plugins in Eclipse that expose their functionalities as GUI widgets. For example, they provide menu buttons. And we want to allow users to use Mesh even with those plugins that do not expose their functionalities as tasks. And so Mesh allows users to define GUI tasks by recording the GUI actions they perform with the HIDE. And basically the user can start a recording of what he does. For example, he can right-click on a class in the Project Explorer, then click on Coverage As, and then click on Coverage button in the window that pops up. And then Mesh automatically creates a task that we call a GUI task. And this task can be combined by the user in a workflow with other tasks, for example, plugin tasks. We know that a user may want to customize these GUI tasks. For example, in different executions of a same task, a user may want to select different classes because he wanted to run those activities on different selections. And so Mesh automatically identifies what could be the customizable inputs. For example, Mesh present as a possible input parameter of the task the 3 items selected during the execution of the GUI task. And so the user can change, for example, in this case, the class that is selected during the execution of the GUI task. We show that the GUI task and plugin task allow users to combine functionalities that are already present in the plugins installed in Eclipse. Unfortunately, this is not always the case because the user may need functionalities that are not already implemented. To this end, Mesh allows users to define new functionalities as workspace tasks just by implementing classes in the workspace and then allowing users to combine these new tasks in their workflows. If the functionalities are not hard to implement, users can just write simple scripts, and we call these scripts script task that can be added to the workflow too. Workflows can be executed just by pressing a run button, and during the execution, Mesh automatically persists the outputs of all the tasks in order to allow users to inspect the outputs also after the restart of Eclipse. During the execution, Mesh provides each task a dedicated folder that we call the task space, where the task can save temporary files, for example. Workflows are written in XML files that can be encapsulated directly in plugins in order to allow the plugin to export the workflow to other plugins. I show you the functionalities of Mesh, and now I want to show you just a brief demo of how Mesh works in practice. I'm switching to a workspace of Eclipse. In this workspace, we have on the right the workspace folders, and we have this debug project which is a Mesh project that is a project with a Mesh workflow, this OML file. And then we have this My Program folder that is a Java project with the bug, and we wanted to find the bug with the debugging workflow that I explained at the beginning of the talk. This project OML file is the workflow, and in this workflow we can see two parts. On the left we have the part of the workflow that execute and export the coverage of passing test cases. On the right we have the execution of failing test cases, and then we have this find bugs task, that is the task that compare failing and passing coverage in order to find the bugs. The cover passing test task is an instance of a GUI task that we recorded just by recording actions like right-clicking on the class and then pressing on coverage as. And this GUI task is the same as the one in the failing test cases part of the workflow, with the only difference that these two tasks are customized in a different way. In the cover passing test task, we have this input, this ID5, that identifies a path, that is the path of the tree item that is selected, that is customized with a workflow input, which is the pathing test. I mean, we are going to pass the name of the class to select with the passing test cases. And on the right we have the same, but with the name of the class that belongs to the failing test cases. And then we have a plugin task that is the export passing coverage, that is a task that is provided by Eclemma, an Eclipse plugin, and the export failing coverage is the same task but with a different instance. And this lines filter passing task is a workspace class that we wrote just to filter out information about the coverage of test cases, because we are not interested in it since the bug is not in the test cases but in the application code. So it is just filtering out coverage information for the test classes. Finally, this find bugs is a task that is exported by a plugin we already developed. We could have implemented a workspace task with the same functionality too. Now I'm going to show you how we can run the workflow. So we go to the Run Configurations dialog. We select this JOpera process because we are reusing the JOpera plugin facilities. And as you can see here, we can modify the name of the passing test class and the class with the failing test, and you can just run. And while the system runs, we can see that first of all it runs the GUI task by right-clicking on a class and then clicking on the window that opens, and then it does all the tasks. So here we can see that the test is going to be selected. Now we are running the coverage, and then the next step is the step about exporting this coverage of the passing test cases. Then what happens is that we filter out the information about the test, and now we are running the failing test and we are exporting their coverage, and now the workflow is going to finish. Now that the workflow is finished, we can open these task spaces, and if we update the content of the folder, we can see that here we have a different folder with the name of the different task instances that we have in the workflow. And we can see that some of the tasks generated some files. For example, here we have this coverage file for the export failing coverage with the information about the coverage of the failing test case. The task produced a result. In particular, we are interested in the results of the find bugs task. And these results can be files or can be objects that can be shown with a proper editor. I didn't told you this before, but plugin developers can associate a custom editor for the outputs of a task. For example, in this case, we created a customized editor for the outputs of this find bugs task. The editor in this case shows us the lines sorted by their scoring, and the score just indicates how probably is that a certain line of code contains a bug. For example, here on the top we have the buggy lines. In fact, if we open this middle finder Java at line 11, we will see that this line is the line that contains the bug. In fact, we see that this is line 11, is the line with the bug. So, and what can do developers also is that they can also associate a configuration editor. For example, here we developed a configuration editor for the export passing coverage task that allow users to select the export format. Now going back to the presentation, I'm going to show you just some results. In order to give an idea of the cost that this mesh approach could reduce, we compared two case studies. The Alpha one is a log file analysis tool that we built by integrating different components, and the bug finder tool that is the debugging tool that just show you. We implemented these two tools by composing the different plugins they are built upon by coding, and in both the cases these required a lot of effort because we had to write a lot of lines of code and modify them because it was not simple to implement this integration, and we introduced some bugs and we had to fix them. And then we draw the workflows that provided the same functionalities, and we saw that the effort is much less because we have just to draw some edges and some tasks, and as you can see, it is much more easier than writing such a huge number of lines of code. So I show you that integrated development environments allow the execution of different tools on the same environment, and these allow users to invent new solutions. But the definition of an automated composition and the automatic execution of this composition is not possible currently. We propose Mesh as a solution that automates this composition. And if you want to try Mesh, you can go to this URL and download Mesh, and Mesh is released with the MIT license, so you can also modify it. Thanks.